students, welcome back to the series of lectures of Intermediate 1B. Now, while we were dealing this chapters of differentiation in which we are discussing the hyperbolic functions. Now, those who have not watched the previous video lesson which I had given yesterday, posted yesterday, that is the hyperbolic functions, inverse hyperbolic functions, their derivatives. Please do check that video in the iCard, then proceed to this video, because here we are going to discuss the solutions for the problems involving the derivatives of the hyperbolic functions. So get it prepared, get them aware of all those formulas, then proceed to this video lesson. And those who have not watched the previous video lessons of the differentiation chapter, do check the channel playlist wherein you can hit all the lessons of trigonometric ratios as well as the differentiation part. Okay, let's quickly dive into the problem here. The second bit, first problem I had noted down. These problems, all the 6 problems in this second bit are involving the hyperbolic functions, right? Now here, find the derivatives of the following functions. X is equal to sine h square of y. So here they are asking us to find the derivative. So let us do the derivative dx upon dy. So deriving with respect to y here. So d by dx of d by dy. Here I am derivating with respect to y. Okay. Sine hyperbolic h square of y here. So this is dx upon dy is equal to, the derivative of sine square is 2 sine h, 2 minus 1 is 1, so sine h of y, and again using the chain rule we should derive the derivative of sine h of y. So the derivative of sine h of y is cos h of y. There is no negative sign, remember, in the hyperbolic functions. Whereas in the trigonometric functions, derivative of sine of y is equal to minus cos, likewise. Okay, so here there is no, okay, so for derivative of the sine of y is just cos of y, but whereas for cos of y is minus sine x. Okay, here the derivative in the hyperbolic functions, we do not get the negative sign for the first 3 hyperbolic functions here. Okay, now let's see here. We have to find the derivative of this, and in the previous video lesson I have discussed about the trigonometric hyperbolic identities, wherein we will shift this cos of h of y in the form of identity cos h square y minus sine of h square y is equal to 1. So this is the identity. So from this identity I will suppose this in the form of sine. So this first let me write this as in the form of dy by dx is equal to 1 upon dx by dy, taking the reciprocal. Okay, so that means this comes to 1 upon 2 sine h of y into cos h of y. Okay, so sine h of y here, sine square h of y is x, isn't it? So we will shift all the function into sine so that we can bring it into the x form. So 2 sine h of y into cos h of y, using the identity I can write it as 1 minus cos square, isn't it? 1 minus sine square, sine h square y. Okay, so this comes to, if you are writing in the form of x, so sine h of y is root x, 2 root x, and 1 minus sine square h. Sine square itself is x, so this is 1 minus just x, not x square. Okay, so we'll bring it, so we got this as dy by dx with respect to x is 2 root. Let us bring this inside. So x minus x square. Here when y is greater than 0 we get the positive, because here it is x h square. So if you take the positive root you get this one. If you are taking the negative root we just get a minus sign. Okay, minus 2 x minus x square when it is a less than 0. These two cases arise. Okay, please pause it and note it down. Second one, x is equal to tan h square of y. The similar way what we have done in the first one, with respect to y, we will first differentiate. Dx by dy is equal to d by dy of tan h square y. So this becomes 2 derivative. We are finding out the derivative. So 2 tan h of y. Again differentiating with the chain rule, tan of h of y, that comes to secant square h of y. We don't have negative sign here, remember? Yes. Now here this is dx by dy. We want it for dy by dx is equal to 1 upon dx by dy. So that is 1 upon 2 tan h of y into secant square h of y. So the second identity, secant square h of y is equal to 1 minus tan square. So using the second hyperbolic identity, write this as secant square h of y is equal to 1 minus tan square. Better write the square for h because hyperbolic functions. Right. So all are in tans. Now we will substitute x value. So dy by dx is equal to 1 upon 2. This is root x. When you are taking this tan square h of y is equal to tan of h of y is equal to root x, you are taking the positive one. When y is greater than 0, you are taking the positive one. Okay. So that means 1 minus tan square means 1 minus x. So this is applicable when y is greater than 0. So I am taking the positive square root. Now if you are taking the negative square root, so again we can do this. Yes, this is 1 minus tan square, right. Here when you are taking dy by dx is equal to 1 by minus 2 root x 1 minus x. Okay. See here we have here secant square. So that is 1 minus tan square. Secant square is. So 1 minus x. I have written x here. Yes, 1 minus x. You can also multiply it and bring it to one side. So this is a negative sign when y is less than 0. Two cases arise. Okay. Note it down. Now the third one, x is equal to e raised to the power of sine h of y. Okay. Sine hyperbolic y also you can mention it either ways. Okay. Deriving with respect to y, dx by dy is equal to e function. E raised to the power of x is the same function. Okay. The derivative of e of sine h of x is e of sine of h of y. Again using the chain rule, because this is not x function, we need to find the derivative of, again let me write, derivative of sine of h of y. So this is dx upon dy is equal to e raised to the power of sine h of y. You can write sine h of y as, okay, let me write sine h of y d by dx of cos of h of y. The derivative of sine hyperbolic y is equal to cos of hyperbolic y. Okay. Now we will shift this into, this is nothing but the reciprocal of the derivative. So this is dy by dx. So 1 upon e raised to the power of sine of h of y into cos h of y here. Okay. So this is e raised to the power of x. This is x. Okay. And cos of h of y also we can write it as, so we cannot write because we don't have that equal x into cos of h of y. Simply this is the answer. Okay. So the derivative of this is 1 upon x cos h of y. Now moving on to the next problem. So x is equal to tan of e raised to the power of minus y. So we will do the derivative with respect to y. So this becomes the derivative of tan of e raised to the power of y. Okay. So this comes to, we can do this tan function is, the derivative is secant square. Here x is e raised to the power of this one. This is our x function, let us suppose. Okay, so tan theta is equal to secant square theta, the derivative. Okay, again using the chain rule we should do the derivative of e to the power of y. So e to the power of y is again e to the power of y. Again we should do in the chain rule derivative of minus y is just minus 1. Okay, so this comes to, we can write it as minus e to the power of minus y into secant square e raised to the power of minus y, right? This is the dx by dy, but we want it for dy by dx is equal to 1 upon dx by dy. So this is equal to 1 minus, you can take it up here, e raised to the power of minus y. Okay, secant square, this is not a hyperbolic function, remember, this is just secant square. So we can write secant square as 1 plus tan square from the identity, 1 plus tan square e raised to the power of minus y. Okay, if it is hyperbolic it will be 1 minus, right? So minus 1, I have taken minus sign here. If the minus sign, negative sign is in the denominator or the numerator, you can give it for the whole fraction. So I had placed it above. E raised to the power of minus y into 1 plus tan square e raised to the power of minus, this is just x, so that is 1 plus x square. So this is the derivative, the whole derivative. Pause it and note it down. X is equal to log of 1 plus sine square of y here. So let me check whether it is a hyperbolic. No, it's not hyperbolic, just of sine y in the textbook. Okay, now differentiating with respect to y. So log function, differentiation of the log function is 1 by x, that is 1 upon sine square of y. Again using the chain rule we have to differentiate 1 plus sine square. So differentiation of 1 is 0 and sine square is 2 sine of y. Okay, 2 sine of y. Again differentiating sine of y, it is cos of y. Okay, positive sign. Okay, 2 sine of y and cos of y. So this becomes 2 sine y cos y. I can write it as sine 2 y. Okay, sine 2 theta. Likewise, you can write it as sine 2y cos y is sine 2y. Okay, so 1 plus sine square. So 1 plus sine square of y here. Okay, this is dx by dy. We can write this sine 2y. Now let us keep it as it is, sine of 2y. 1 plus sine square of y. Here x is log of this, so 1 plus sine square of y is e to the power of e, here e raised to the power of x. You can write it. So this is dx upon dy. So I want dy by dx. So 1 by dx upon dy. So that comes to 1 upon sine of 2y divided by e to the power of x. So this comes above. So sine of 2y is the final derivative. Now there is no hyperbolic function involved here. Now moving on to the next one. Here let us see, this is dx by dy. Okay, so 1 by, so log function, so 1 by derivative of the log function is 1 by x, that is 1 by root y, 1 plus root y. Again deriving this derivative of 1 is 0, derivative of this is 1 by 2 y to the power of 1 minus 1 by 2 minus 1 by 2. So that comes to root y below. Okay, y raised to the power of half minus 1. So that is minus half. So coming below here. That's it. Okay, and we have we do have the derivative of dy by dx. Now with respect to y only we are doing. So that's it. So let me write here dx upon dy is equal to 1 by 2 root y 1 plus root y. Okay, we got this, and so dx by dy is equal to we want 1 upon so 1 upon dx by dy. So this is equal to dy by dx, isn't it? So that means So shift it to this other side, 2 root y, y plus root y. So multiply 2 root y plus 2y. So this is the final derivative. So have you noted down? Here, with this we have completed the section, the second bit. In that 6 problems I have completed, few involving the hyperbolic functions, few are involving the just log functions. Okay, we will see the next problems in our next video lesson. Thank you all.